My name is Maheshwar and today I am going to teach a topic that is limit. The topic is limit. Right. So in this video, our main objective is the concept of limit, and then we will learn two types of limit, that is left hand limit and right hand limit, and after that we will learn how to evaluate a limit. So let's start. Suppose there is a bridge. Suppose there is a bridge, right? And you are just crossing this bridge, right? There is a bridge and you are just crossing this bridge, but there is a condition that each time you just have to cover only half of the distance, right? At first you just cover this distance, and after that another half of the distance, and then this and this, and so on, right? Now the question is, will you able to cross the bridge, right? Will you able to cross the whole bridge? So the answer to this question is quite easy, and the answer is no. The reason is that actually each time you are just crossing only half of the remaining distance, and the other half is still remain to cover, right? Each time you are just covering only half the distance and the other half is still left behind. So that's why you are never going to cover the whole bridge. You are never going to reach at the other end of the bridge, right? But you can see that, just imagine, each time you are just adding some distance, each time you are covering some distances, right? It means you are approaching, you are getting close to the end of this bridge, right? So each time you are getting close to the end of this bridge, and the idea of getting close to something is nothing, it is limit. Okay, so the limit is nothing, it's just the idea of getting close to something, right? So let's do this mathematically. Suppose you have a function f of x equal to x square minus 1 upon x minus 1, where x is not equal to 1. You can clearly see that this function is not defined at x equal to 1, right? But we want to check its behavior around the point x equal to 1, in the neighborhood of the point 1. So for that, what we will do, so as this function can be written as x minus 1 into x plus 1 upon x minus 1, right? Which is cancelled, these two things are cancelled out, and so this, okay, this function is x plus 1, right? Now just study this table. Value of x, and here value of f of x, right? Suppose when I put the value at when I put value 0.9000, right, my function value would be 1.9000, right? When I put x equal to 0.9900, my function value would be 1.9900. Similarly, for x equal to 0.990, my function value would be 1.9990, right? So for 0.9999, my function value would be 1.9999, right? From this table you can see, as my value of x is approaches to the point 1, as my value of x is approaches to the point 1, my function value is approaches toward the point 2, right? As the value of x is approaches to point 1, the function value is approaches to point 2, and this is called what? Limit. And this is called limit, right? So what is the definition of the limit? So this is just the idea of the limit. What happens when we find the limit of a function. So now let's come to the definition. It's only informal way of defining a limit, right? So a real number L is said to be a limit of function. A real number L is said to be a limit of a function f of x at x equal to some point, say a, if this condition satisfied. And what is that? Your f of x approaches to that point L whenever your x approaches to point A, right? So any real number L is said to be limit of the function at x equal to A, means whenever you are approaching to the point A, right? Whenever you are taking values near the point A, your function value are taking the point near the point L. It means whenever you are approaching to the point A, your function is just approaching toward the point L. This is the way of saying that function is approaching toward the point L, right? So now let us do this graphically. Suppose this is the graph of a function, right? And you are defining, suppose this is point A and here this is point L, right? So let us try to approach towards the point x, right? Here my function value is, you can see this, right? Say this is f of x1, right? So when I reach here, my function value is here, right? So as I am reaching toward the point A, my function value is like this. So you can see, as I am reaching toward the point A, my function values are increasing or reaching toward the point L. Similarly, from the other side, you can see at this value, my function value is here, right? So when I reaches toward the point, when I just get closer to point A, my function values here, this correspond to this, right? The graph is not perfectly, but it just look like this, okay? So you can see when I am approaching towards the point A, from the right hand side, you can see my function value is again approaching to point L. So this means whenever I am approaching toward the point A, my function values are approaching to point L, and so this L is my limit of function f of x is this is the limit of the function. And how to denote this? We denote this like this: limit f of x is equal to L when x tends to A, right? This is the way of denoting this, okay? So as you can see, you can approach toward the point A from the both direction. Either you can approach from the left side of the A, and you can approach from the right side of the A. So based on these two directions, we have two different types of limit, right? And they are left hand limit and right hand limit. So what is left hand limit? Left hand limit. This is, so limit f of x, when your x approaches to point A from the left side, that is from left side, right? So when you are approaching to point A from the left side of the point A, it means the limit so obtained is called left hand limit. And say let us denote this like this. And similarly, right hand limit, right hand limit, right? So this is limit of function f of x when your x is approaches to point when your x is approaches to point A from the right side, that is from right side, right? And suppose you get the limit L, we denote it with L positive. So the left hand limit, for the left hand limit we just put minus A over the head of A, and for the right hand limit, as we just put plus sign over the head of A, right? So whenever these two limits are equal, we say that the limit of the function exists. That is, whenever your L negative is equal to L positive, that is left hand limit is equal to right hand limit, then we say that the limit exists, right? Then we say that the limit exists, right? So this is the definition, the concept of limit. Now we will learn how to evaluate a limit of a function, right? So there are actually a lot of different ways to evaluate the limit of a function, but the most common way is the direct substitution. The most common way is direct substitution. Suppose you are given a function f of x equal to say x square plus 3, right? Then the limit of this function f of x when your x approaches to say point A is equal to nothing. We just put the value of x at the given function. So my limit would be A square plus 3, right? This is the basic way of evaluating the limit, but there is most important way of how to evaluate a limit, that is indeterminate form, right? Suppose indeterminate form. Sometimes after substituting the value of x while finding the limit, you get something like this: 0 by 0, or infinity by infinity, or infinity minus infinity, etc., right? So in that case, what we have to do, we just try to we try a different approach. Sometimes this situation can be handled by series expansion, right? Sometimes we use some identities, but the most common way of handling this kind of situation is the application of the L'Hospital rule. L'Hospital rule, right? So what this rule says, that suppose you are going to find the limit at x equal to a of the function f of x upon g of x, right? So according to this rule says that this limit is nothing, it is equal to the limit x tends to a, your f dash of x and g dash of x. According to this rule says that your limit is nothing, the limit would be same, either you just directly find the limit of this, or you just differentiate the two function, that is differentiate the numerator and denominator, then apply a limit. So both will be same. Okay, so this is a way of handling such kind of situation. So now we will do a problem on this rule, so that this okay, so let's do this. So question is, suppose there is a function whose value at x equal to 0 is 0, and derivative f dash of 0 is 1, and question is find the limit x goes to 0 of this summation of f of x by n, where n goes from 1 to say k, right? We have to find the limit of this thing. Okay, so solution would be First of all, we just expand this as it is a series expansion. So what is that? This is nothing, it is just like this. It is f of x by 2 plus so on f of x by k, right? And in the denominator there is, in the denominator there is x, okay? So in the denominator there is x, right? Now when you apply the substitution method, then you will get like this: f of 0 plus f of 0 and so on, f of 0 in the numerator, while in the denominator you will get 0, so which is equal to 0 by 0 form, right? Quite you can see clearly, because the value at x equal to 0, it is 0, so all these are equal to 0, so the numerator is also 0 and the denominator is also 0. So now we will apply the L'Hospital rule to this situation. So according to L'Hospital rule, the limit of this is nothing, it is just equal to limit of the derivative. So x tends to 0. First differentiate the numerator and denominator, which is f dash of x plus f dash of x by 2 into 1 by 2 plus so on f dash of x by n into 1 by, it's a k, okay? And in the denominator you will get 1, right? Now on applying the limit you will get so it is f dash of 0 plus so on f dash of 0 into 1 by 2 plus so on f dash of 0 into 1 by k, right? So this is nothing, this is equal to, as the function f dash of 0 is your 1, so this is equal to 1 plus 1 by 2 plus so on 1 by k, right? And this is the required answer, right? This is our required answer. So let's recapture, let's summarize what we have done. First, we have studied the concept of limit, right? What is limit? We just it is just the idea of getting close to something, right? It is just the idea of getting close to something, or we just want to check the behavior of a function at a particular point, right? Just in the neighborhood of that point. And after that we have studied the two types of limit, that are left hand limit and right hand limit, based on the direction of approaching towards the point. And after that we do some ways of evaluating the limit. One is direct method, that is substitution method, and then one we have done, that is indeterminate form, and L'Hospital rule, how to handle the indeterminate form is using the L'Hospital rule. And there are also another ways of handling such kind of situation, but this is quite useful. So that's it. Thank you so much.